So in learning to write Lewis structures, we came across this molecule, carbon tetraiodide, and we found and determined that the proper Lewis structure was this. Okay? Now, I'm going to introduce a term to you, something called formal charge, and that is if we sort of split up the electrons and shared them, so we split up all the electrons that are in bonds, and we just provided half to one atom and half to the other, what would the charge of each atom be? That's a very complex definition of what formal charge is. Probably the most useful definition of formal charge is that formal charge is a number or a value that we can use to determine whether we have written a proper Lewis structure. And the reason for that is that things in nature, molecules in nature, tend to form such that formal charges of atoms are relatively small. They are 0, or they are low numbers like 1, in some cases 2. There are cases where they are larger than that. But the larger the formal charge, the less likely that structure is going to truly be found in nature. So formal charge will allow us to pick between different resonance structures. So if we have a choice between two different Lewis structures that both look appropriate, both have octets fulfilled, and they have the correct number of valence electrons, how do we choose which one would be the right one? And we saw an example of that in class, but we're just going to start talking a little bit about what formal charge is and how to calculate it right now. So what we're going to need to know, again, is how many valence electrons each atom would have. So we're going to do this formal charge thing for carbon, all right? And we know that carbon has 4 valence electrons, and we know that iodine has 7 valence electrons. And what we're going to do is we are going to count the number of electrons around each atom, okay? So we're going to look at what the formal charge of each of these compounds would be. And to do that, we're going to have to count the bonds a little bit differently than we have previously, all right? Previously, we have looked at a bond and we have counted a bond as a pair of electrons. But to calculate formal charge, we are going to have to determine, all right, or split up those electrons in that bond a little bit differently. You'll see what I mean here in a second. So we're going to take a look for this iodine atom right here. We're going to count the number of electrons around it, all right? Not the total number, but remember with formal charge, we split the electrons in the bond. So bonds count as 1, each electron counts as 1. So there'd be 1, 2, 3, 4, 5, 6, 7. We take that 7, we subtract it from the number of valence electrons. 7 minus 7 is 0. So the formal charge on that iodine is 0. It's going to be the same for all these other iodines because they are exactly the same. Formal charge of 0. Remember we said formal charge of 0 is about what we expect if we've written a proper Lewis structure? Now let's take a look at carbon. All right, carbon doesn't have any lone pairs around it. We can't just count those electrons as 1. There are none there to count. But it has 4 bonds, and remember we count bonds as 1 electron. We're splitting them between the 2 atoms. So 1, 2, 3, 4. 4 electrons, valence electrons that it has, minus 4 that we counted, equals 0. So a formal charge of 0. That is a very likely structure that we would see in the environment, that we would see in this world. This structure is very likely because it has and produces formal charges that are very small, 0 in this case. That makes it a very likely structure that we would observe in nature. Right? That's how you calculate formal charge. We're going to see how to use it to choose a proper resonance form or resonance structure of a molecule here in the next problem.